So today we are going to be looking at line graphs. Yesterday or Monday we looked at histographs where you put things in intervals, and today we're going to talk about line graphs. A couple terms that you are going to need to know. First one being horizontal. Horizontal is straight across. Think the horizon. Think like a sun coming up. Why can't I change the colors? There we go. Like the sun coming up. This is the horizon. And then think vertical. Vertical is up and down. V for vertical, it's kind of up and down like that. So horizontal and vertical. Let's look at this, line graphs. Danny created a line graph for the data he collected for the high and low temperature over 10 days. What values, let's go down to A, what values are on the horizontal? The horizontal. What is that right here? The day. Now let's look at the vertical. What is on the vertical? The temperature. How does the data change over time? Well, on the day, here we go, what is that, the low temperatures? Does it seem to increase over time? Same with the high, it seems to increase. So that's how we can look at a line graph. This line graph shows the height in inches for a boy from the age of 5 to 11. Right away, what can we see happening? It increases. What can we say about the change in boy's height over years? It increases. I just said that. What is the height when he was 8 years old? So let's look for 8 and go straight up and straight over. He was 40 inches. We forgot to look at the horizontal. The horizontal is in age in years, and the vertical is height in inches. So how old was he at 35? Let's go horizontal 8 years, and then go to the vertical 40. Between which age did the greatest increase in height take place? Well, let's look really carefully at this data now. Which one had the biggest jump? How much from 5 to 6? It was about about 35, about 5 inches. And this one looks pretty big. From this to this, so from 9 to 10. Let's look at from 9 to 10. 9 he was at about 40, 10 he was about 50. So I think it's between 9 and 10. Do you see how you can read that? Right. I want you to try these on your own. This graph shows the average value of a car versus its mileage. On the horizontal, we have miles in 1,000. On the vertical, we have the car value in 1,000. So according to the graph, what happens to the value? Actually, back up, pause it, and see if you can answer these questions on your own. And then come back, unpause, and I will go over the answers. Okay, according to the graph, what happens to the value of the more it is driven? So the longer it's on the road, it decreases in value. So it decreases. Ooh, that's really bad. Let's undo that. Let's go to the like this. So it decreases. About how much could the owner sell the car for if the mileage on the car is 70,000? So this is in thousands, 70,000. About how much? So right here and over, about $5,000. Make sure to put the $sign. And then last but not least, the car is being sold for $10,000. The mileage is 50,000. Is this a good deal for the person buying the car? So let's go up to $10,000. Here's 10,000. And if I go over, I would think it would be about 40,000 or 40,000? 40,000 miles, and the mileage is 50,000. Is it a good buy? Yes or no? Sorry, I had to really think about that one. So the car is being sold at $10,000, and I would think that it would have about 40,000 miles on it, but there's 50,000. So it's going to be good for the seller, but not the buyer. The buyer, I think, should get the car for a little less. So is it good for the person buying the car? Not so much. All right, go on to exercise 3. All right, I just want to get you started on the homework. The table below shows the weekly incomes of 50 students. Find the average income rounded to the whole number of the students for each age. So for age 14, you are going to add, hold on, let me highlight this. You're going to add all these numbers and divide by how many numbers you added. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide by 9. Here we have, so on 15, you're going to add these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And divide by 10. So then 16, you're going to add and divide by 9. This one you're going to divide by 11 and 11. You can use a calculator for these. Even though the value is 0, you still need to count that as a piece of data. So find the average weekly incomes for all of these. Then you are going to add the graph. For the horizontal, you always want something that is constant, like the age. The age, it doesn't depend on anything. So the age goes here. And what I told the class is that since there's such a big space, I would do like 14, skip 1, 15, skip 1, 16, skip 17, skip 18. You don't have to, but I kind of like that. And then the values go from 0 to 110. So I'd start 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100 and 110 right here. You can fill in all the values. You don't have to. There you go. That's getting you started for the homework. Next chapter, pie charts. We have looked at line graphs. We've looked at histographs. And now we are looking at pie charts. Another name for a pie chart is, what shape do you see here? Yep, a circle. So it's called a circle graph as well. A pie chart is synonymous for circle graph. So right here it says the table shows the number of t-shirts of different sizes sold at a shop. So small, 9 t-shirts were sold. Medium, there were 18 sold. Large, 6, and extra large, 3. So how many total? 36. If I would add 9 plus 18 plus 6 plus 3, that would equal 36. So now, 1/4 of the shirts are small, and that is indicated right there. Half of them are medium, a 1/6 are large, and a 1/12 are extra large. That equals a whole, or 100%. Or one whole. One whole, or 100%. One thing that I failed to mention was in a circle graph or a pie chart, notice 1/4 What type of an angle would be at 1/4? Do you know what angle that is? Most of you would think it's a right angle, 90 degrees. Well, if you think of the degrees of a circle, how many degrees would a circle be? Yes, 360. So if this is 90 degrees and 2 of these is half, this would need to be another 1/4. Let's look at this one. There are 200 chairs in a warehouse. 80 of them are plastic chairs, 30 are metal chairs, 40 are wicker chairs, and the rest are wooden chairs. The pie chart represents the number of chairs of each type. So this whole equals 1, or 100%, or 200, because there were 200 chairs total. What type of chair is found in the greatest quantity? Well, between 80, let's fill in these, 80 plastic, 30 metal, 40 wicker. If there were 200 total, I would just add 80 plus 30 plus 40. I'm going to add 40 and 30 is 70. 70 plus 80 is 150. So I'm going to subtract that. So wooden chairs must be 50. What type of chair is found in the greatest quantity? Plastic. How many wooden chairs are there? I already did that, 50. What fraction of the chairs are plastic chairs? So let's look at plastic, and it's 80 over 200. I would not keep it that way. I would reduce it down to, I could reduce that to cross off a 0, cross off a 0, 8/20. And I see that 4 goes into both as well. 4 goes into 8 2 times. 4 goes into 25 times, so 2/5. And then finally, how many times as many plastic chairs are there as wicker chairs? Well, plastic there's 80, wicker there's 40. So how many times do they have plastic chairs? 2 times. Okay. All right, let's look at this one. A pie chart. The pie chart represents the amounts of money collected by various booths at a carnival. One thing that I noticed right away is if this is 1/4, I know if this is 1/4, I know that that would be 4 pieces, so 3,000 times 4. Total is going to be 12,000. And if this is a right angle, and so is this, I know that game booths is 3,000 as well, which gives me 3,000 and 3,000 is 6,000. I have 6,000 left, and I know that food booth is 4,800. Subtract. Can I take 0 away from 8? No, gotta borrow. 10 minus 8 is 2. 5 minus 4 is 1. So music booth must be 1,200. Let's see if we've answered all our questions. What fraction of the total amount of money was collected by the game booth? So game booths, we know right away that that was 1/4 because it has a 90-degree angle. What was the total amount of money collected by various booths? So what was the total amount? We had that right here, $12,000. Make sure to put the $sign. C, how much money was collected by the music booth? Well, the music booth, we figured that out by knowing that total is 12,000. Take away these 2. 3 plus 3 is 6,000, so subtract 6,000. Then take away the foods booth. It's left with 1,200. So how much money? 1,200. Oops, changed my color. Okay, you get the idea. What was the ratio of the money collected by the food booths to the money collected by the handicraft booth? So I have, let's go over here, 3,000 to 4,800. Let's reduce this. 1, 2, 1, 2. What number can go into both of them evenly? 6. I can reduce that to 5/8. 5/8. What is the ratio? 5 to 8. All right. There you go. It is to complete exercise 4.